We are the TAC team, and this is our project, the GreenRover. I am Elijah Sheldon, the team leader and the autonomous lead.
I'm Justin Allen, the analysis lead and mechanic.
I'm Hang Chan, and I'm the drivetrain and power lead.
I am Natamon Laurapan. I am the coding lead.
Our objective is to take this rover and convert it from a gasoline engine powered rover into an electric motors powered rover.
Alright, so there are a number of advantages to converting. Less maintenance, no exhaust emissions, you can run it inside, less noise, easier operation, and less cost to run in the long term. So first, we needed to remove the combustion engine and the hydraulic system, and then we performed calculations to determine what type of motor we needed to meet our design requirements. Then you can see we installed the motors over the rear wheels here. We also replaced the belt and pulley system with a chain drive. We also installed a number of sensors and coded them. And we also programmed the rover for autonomous waypoint navigation.
For the motors, we want two 24-volt, 350-watt motors. We're using DC brushed permanent magnet motors because they have a linear curve, so they're more predictable, easier to use and control, and they also have a good starting torque. For the decision factors, we need the motors to be powerful enough to move a 100-pound rover to 15 miles per hour on level ground, and also able to climb an incline of 15 degrees. The motors drive the wheels directly through sprockets and chains, and the gear ratio gives us more torque, but less speed.
For the components on our rover, we have two systems, the drive system and the sensor system. The drive system, we'll start with our remote transmitter. We will send to the receiver over here. It will send down to the Arduino Mega, our main microcontroller board. It will do all the coding for the sensors and the drive system. In this case, the Arduino will send the signal down to the motor controller down here. The motor controller will determine how much current from our batteries is let into the motors from our transmitted signal. The fuses in between on the batteries, we have an 80 amp fuse, and next to the current sensors, which we'll get to, there's 50 amp fuses. There's a main contactor that's out of view over here that holds up the middle of the current, and that will be switched off with the emergency stop. The emergency stop is in case the rover runs away, then we'll just hit it really hard and it turns everything off. The switches, we have our motor switch on the side and our electronic switch on the top. For the sensor systems, they work off the electronic switch. We have the Arduino Mega, and Arduino Uno on the side. The Uno will keep track of our speed sensors, which are on wheel encoders on the rear wheels. The speed sensors will send the information to the Uno. The Uno will send it on to the Mega. We have a GPS on the back for autonomous navigation, mainly. We have our inclinometer, which is our tilt sensor, right here in the middle, and our current sensors, one in each motor circuit. And all those sensors are connected down to the Arduino Mega, which will do all the main processing and will send out the information to our data logger on the side for analysis.
For testing, we are doing two tests. The first test is an incline test, driving the rover up a slope of 20 to 30 degrees. The following video is the incline test that we took in front of Chacha Village. The second test is skid steering. Since both left wheels are connected together and both right wheels are connected together, the rover can turn in place by rotating one side forward and another side backward. The following video is a skid steering test.
Autonomous waypoint navigation. The rover will determine when it's in autonomous mode based on one of the modes that we send using the remote transmitter. Using the GPS, it will determine where its latitude and longitude is and will then drive itself to a pre-specified latitude and longitude point or a waypoint. The following video is our waypoint navigation. That concludes the GreenRover project. Thank you for watching.